Hello friends, welcome to channel DevOps Consultancy and Solution. In this video, we will learn about application security. We will understand what is application security, what is its importance, and why we need it. We will learn brief about static application security testing, dynamic application security testing, interactive application security testing, and runtime application self-protection. So let's get started. So first we will understand what is application security. So application security refers to measure and practice taken to protect the software application from vulnerabilities and threats. So what does it mean basically? So we in the application security we will follow some practices to where we can protect our application from vulnerabilities and the external threat. So it is a practice in which we aim to safeguard our application from external attacks throughout their life cycle. So in the software development life cycle, from design to development and deployment and to maintenance, right? So by using a wide range of tools and techniques, activities, strategies, and preventive actions and detective steps we taken to secure the application from external attacks. So when we say the preventive action, so before we deploy the application or even after deploying the application on the server, we follow some security tools to scan the application so we can protect our application from any external threats. So we do some detective actions and follow the procedure to identify if there is any external attack on our application, so how we can protect it. So now we will learn about what is the importance of the security testing. So first is we need security testing to protect the sensitive data. So many applications or almost most of the applications somehow manage the personal data or the financial records or the customer data or in any kind of data which is very sensitive or the PII data. So security testing helps to protect that data from the unauthorized access and from the data breach. So second is preventing data breaches and financial loss. So security application security helps to avoid the costly data breaches and which can cause financial loss and the legal action. So application security help us to protect our application from these kind of financial loss and legal actions by avoiding the data breaches. So next is avoid downtime and enhance business continuity. So application security avoid the downtime by causing the external cyber attacks like ransom or hackers, which ensure that our application is always up and running and always increase the business continuity. So next is the compliance and the regulation. So many industries follow the regulations like GDPR, HIPAA and PCI. So application security helps to prevent to non-compliance which can result in severe fines and legal repercussions. So with the application security, we always ensure that our application always complies with the GDPR, HIPAA, PCI and the other uh, industry standards. And last but not the least is build and enhance customer trust. So any application in which our data is protected, so it increase the customer trust, it build the relationship with the customer and increase the organization reputation. So from user point of view or from yourself, if you can think, if any organization or any company which is protecting your data and taking care of your data, then you can always trust on that organization or the company. So it will increase the customer confidence and trust with the organization. So next is the key components of the application security. So first is the development practice. So we always follow the developers always write the code to secure the application by using the proper guidelines and avoid the vulnerabilities like SQL injection and cross-site scripting. So regular tools like SonarQube or checkmarks, though we integrated into the build pipelines, which keep scanning the code and give the code reviews to the developers so they can implement the best industry standards. So next is the authentication and authorization. So it always ensure that the unauthorized access is always blocked in the application. So there should be a permission which are you based on the user roles by using the RBAC, implementation of the strong authentication and the multi-factor authentication like MFA mechanism. So next is the data protection, encrypting sensitive data in transit and at rest, and using the secure method for data storage and transfer. So it is very important to encrypt our data in transit and at rest when we are transferring from one component of the application to the another. Right. So next is testing and vulnerability management. So when we deploy the application on the application server and it is up and running, so it is also very important we keep scanning the application by using the dynamic application security testing tools to identify the vulnerabilities at runtime. So regular penetration testing help us to protect the application from any kind of attack and secure provide more security to the application. Next is the monitoring and alerting. So whenever there is an alert or threat, so implement the application logs and monitoring so we can protect the application from the any kind of the alert. Having a robust incident response plan to address the security incident. If there is any kind of incident occur on the in the application or in the system, so we should have a robust incident response plan so we can protect our application. And last is the security patching. So always keep your software up to date with the latest security patches. So next is what are the types of security testing. So currently there are majorly four types of security testing that we are using in the application security. First is the SAST, which is we call it SAST, the static analysis security testing. So it's a type of a testing that we analyze the application source code to detect the vulnerabilities. So next is the DAST. So DAST is a kind of a testing to identify the vulnerabilities and misconfiguration in the application while it is running. So next is the ISAT. So interactive application security testing. So it's a combination of both SAST and the DST, which is dynamic application security testing. And last is the runtime application self protection. So RASP. So it's a kind of a security technology or a technique in which integrate with the application which is running on the production. So it helps to detect and block the attack in the real time. So this is very important and the very useful kind of a security testing. If we have a very critical application which we need a protection, high security, then this kind of testing is really important where we can integrate the agent with the runtime application, which help us to detect and protect our application from any attack at real time. Okay. So now we will talk about static code analysis testing. So what is static code analysis? So SAST is a type of security testing that analyze an application source code binaries to detect the vulnerabilities at the development phase. So for static code analysis, we don't need to execute the application. It is a white box testing technique that we use during the development phase of the software development lifecycle. So static code analysis help us to find the vulnerabilities at the development phase, so developer can fix those vulnerabilities at very early stage of the development, even before compilation. So next is when and where we can use the static code analysis. It can be used in the development phase. Developer can integrate it with their IDs and fix the bugs while writing the code. DevOps guys can integrate it with the CI build pipeline, run it along with the compilation and set the quality gates. If there are major or critical bugs, then they mark the build fail and send a report back to the development team so they can fix the bugs and they can improve the quality of the code. So next is advantages of the static code analysis. First big advantage is early detection of bugs, which help us not only to protect application but also to reduce the cost required to fix the bugs in the later stage of the development. So second is the comprehensive analysis. It gives detailed analysis report and helps developer to identify bugs and fix that. Next is improve code quality. It highlights the bad coding practice and improve good coding habits in the developers. So which means it will improve the code quality. So next is the disadvantages of the static code analysis. So first is the false positive. Sometimes report issue vulnerabilities that are not actual and generate false alarm. So it requires manual review and put lot of developer effort to analyze it. So next is the limited context, which means it does not analyze the runtime behavior of the application and that the nature of because that is the nature of its static code analysis. So next is the language specific. Static code analysis tools don't support all the languages. So we have to be very careful while choosing the tool for static code analysis, whether it really support your application or not. So next is what are the most popular tools available in the market. So first is the Sonar Cube, Checkmarks, Snake and Vericoda. There are few other tools which are also available in the market, which are Coverty, Findbugs or Codacy. So these are the famous one and majorly used by the lot of organizations. So next we will discuss about dynamic application testing. As the name says, it tests the application in the dynamic state, which means at the runtime. Dynamic application security testing is a testing method which is used to identify the vulnerabilities or misconfiguration in the web applications or API or the mobile application when they are running. It does not require access to the application internal code and it is suitable for testing like third-party libraries and open source component where we generally don't have an access to the code base but just binaries. So when we have the binaries, so these tools really help us to find the bugs and the vulnerability in those binaries. So next part is when and where we can use it. So dynamic application testing can be used at QA or at the stage environment, but we generally prefer to test it on the QA environment. So we can find the bugs in the early stage as part of the shift left security strategy. So if you guys don't know shift left security strategy, it is a strategy in which most of the testing is being done in the early phases of the pipeline to find bugs and vulnerabilities. I will discuss this topic in detail in some other video. So dynamic testing can also be used for the API testing. It can be included in the continuous deployment pipeline and set the quality gates where and mark the pipeline fail in case the critical of the major bugs. Dynamic testing can be done on production environment only by using the non-intrusive tools. So non-intrusive means the tools which don't impact the performance of the application and the system. But generally dynamic testing is done on the pre-production environment. So now let's discuss about the advantages of the dynamic testing. First is the real-time analysis, which means it identifies the vulnerabilities in the runtime application. So next is the third-party library scanning. As I said earlier, it is very useful for third-party libraries and open source component testing where we don't have an access to the source code. Next is the detect runtime issue and scalable. So dynamic security testing can easily be integrated with the deployment pipeline as a part of the DevSecOps. So next we will talk about the disadvantages of the dynamic testing. So first is the false positive. Sometimes Tools publish report for false vulnerability which can cause the developers to struggle to find the root cause of the bug. So next is library context. Because of lack of code access, tools don't provide insight the cause of the vulnerabilities. So next is the performance impact. Because the scan is running on the QA stage environment, so application performance is impacted sometime. So next we will discuss about the tools. So there are a lot of tools available for the dynamic security testing, but major ones are Acunetics, Burp, Zap, W3F, and Qualys. So next is the interactive application security testing. So in interactive application security testing is an approach where we can use both the SAST and the DAST. So it identifies the vulnerabilities in the application when they are running either by the real user or by the automated test runners. So in the IAST testing, we require an agent that we embed into the application or a server to provide deep insight into how the code and the application is behaving while executing. Okay, so when and where we can use, we can use it during the in the CI/CD pipelines, where you can integrate the as tools in the CI/CD pipeline for continuous feedback of the vulnerabilities during the development. And so we can use the IS while the application is being tested in the in the real time on the QA environment or on the stage environment. So IS is a very helpful in the development and the testing phase of the software development lifecycle. So as I said, so we can you or the developers can integrate in the IDs, or developers can or the DevOps team can integrate this tool with in the CI/CD pipeline. Next is the advantages for the IAST. So it has high accuracy because of the combination of the SAST and the DAST. So it helps to reduce the false positive and the negative. So it has a very high accuracy as compared to the SAST and the DAST. So it gives a real-time feedback. So identify the vulnerability during the application while we are executing, and provide a very detailed information. Right? It is very easy to integrate. So you can integrate in the IDs. Developers can integrate these tools in the IDs, or DevOps guys can integrate in the CI/CD pipeline for the continuous testing. So when we talk about the disadvantages, so first it is the performance impact. So sometimes because it gives you a because we are running it while executing the application, and it gives a detailed information. So sometimes it will slow down the application during the testing, right? So next is the complex setup. So as I said earlier, so it is easy to integrate, but sometimes it is really difficult to embed the app agents in the legacy applications, or require a lot of configuration and maintenance. So because of the nature of these tools, like it cover both SAST and the DAST feature of the testing tool, so its cost is quite little bit higher than those two. It is little bit expensive as compared to SAST and the DAST solutions. So what are the tools which are the most popular in the organizations are SCL AppScan, Veracoda, Zap, or W3AF. So next is the runtime application self-protection. So runtime application self-protection is a security technique that integrates directly into the application to detect any vulnerabilities and block the attacks at the real time. So when the application is really running on the production, it helps to monitor the application behavior, data flow, and the user interaction, and allowing to identify and block any uh, uh, unusual activities or the in the application. So RASP operates within the application itself and provide deep insight, context, and insight about the security threat. So when and where we can use? So we can use the RASP tools on the production environment. So it gives a really high we can use these tools for the high security applications like the banking applications or the healthcare or the government apps or the financial institute apps. We can use them. So we use these applications for the web application or the API or the microservices, where we can protect the application from any threat like SQL injection, XSS, and any other hackers attack. So next is the advantages of the RASP tools. So one of the biggest advantage of this tool is real-time protection. It protects your application when it is actually running on the production. So next is the deep context awareness. So when we it gives, it helps to monitor the application behavior and identify attack with high accuracy. Easy to integration. So it is very easy to integrate with the application without any major code change. So it reduces the false positive because it gives the high accuracy and give you detailed insight of the application context and the data flow. So when we talk about the disadvantages, so it is the one of the biggest disadvantage of these kind of tools is the performance of overhead, because these tools are running on the production. It can introduce the latency or affect the application performance during the runtime monitoring. So next is the complex configuration. So it requires careful configuration and tuning to minimize the disruption. So next is the cost. It is very expensive tools for as compared to the traditional security solutions. So next is architecture challenge. It requires integration with application at runtime, which might be challenging for some architecture, especially legacy applications. So next is the comparison. So in the comparison, it's just like the short summary and a quick recap. So when we can use these tools and what are the approaches and what are the various features we can compare. So SAST, as I discussed, it's a development phase. DAST we can use on the testing. IAST again on the testing, and RASP is basically for the production phase. SAS is the white box testing. DAST is the black box testing. ISAT is the combination of both, and RASP is the real-time monitoring. So next feature is the vulnerability detection. When we talk about a vulnerability detection, so SAST is the early detection of the vulnerabilities. So DAST is the detection at the runtime. Again, ISAT is the accurate detection. Again, it is again at the runtime. And last, RASP is the real-time detection and the mitigation. So next feature is the accuracy. So when we for the SAS, it's a moderate. So which is basically, it may generate sometimes a false positive due to the lack of the runtime context. DAST is basically moderate to high. So less false positive but limited context because of the not access to the code. So ISAT is the high accuracy because it is a combination of analysis of both runtime and the application code like SAST and the DAST. And RASP is basically a very high accuracy because it detects and block attack dynamic based on runtime behavior. So next is the false positive. SAST has a high false positives because due to lack of the runtime context. So DAST has low to moderate false positives because of its runtime behavior limits false positive. ISAT is low. ISAT has low false positive and because of the context aware detection and reduced false positive. And RASP is very low because it analyzes actual runtime data for precise detection. Right. So next is the coverage, or we can say area of scope. So SAS cover the entire code base. So it can scan your entire code base to find the static vulnerabilities like SQL injection or XSS or many others. DAST is to cover vulnerabilities and in exposed API or the user interaction at the runtime. So I said it provides both static and insight and runtime vulnerabilities. And again, RASP, this runtime behavior and real-time threat mitigation. Next is the performance impact. How these tools has the impact, performance impact on the application. So SAST has no impact on the application at the runtime. So DAST has the minimum impact on the application because we are running these tools on the either QA or stage environment. IAST has the moderate because we are running these tools on the stage environment or the QA, and also part of the build pipeline for the we are using it for the SAST and the test combination. RASP has a very high performance impact because we are using these tools on the real-time production environment. So next feature is the integration with the CI/CD. So SAST, it is very easy to integrate with the CI/CD process. DAST, it again I will say it is very easy to integrate in the deployment pipeline. ISAT, very easy to integrate, there is no problem. And RASP, we can't integrate with the pipeline because RASP tools comes into the picture after the production deployment. So now we come to the conclusion part. It is recommended to use 2 or 3 security tools to enhance the application security and detect vulnerabilities. You can use these tools in a combination of 2 or 3 to secure your application. More the application is secure, enhance more customer trust and reduce the financial loss. You can use SAST with IAST with RASP. So that's all from my side. Hope this video is very useful for you all and give you brief and clear idea about the application security testing. Thank you guys. Don't forget to like, share and subscribe of my channel. Keep learning. Happy learning.